Welcome to day 1 of Python Basics. Today we're going on a Python functions adventure through a monster maze. Feeling lost when your AI coding agents generate Python code? You're not alone. Many developers stare at unfamiliar syntax, wondering how to interpret the logic behind their agents' creations. This crash lesson will banish that confusion forever. We'll explore Python's fundamental data types, common operations, and basic control flow. You'll gain the confidence to read and understand any code your agents generate. Stop feeling sidelined and start truly collaborating with your AI. Let's unlock the power of understanding code, not just generating it. How will we learn all this? By creating a mini text-based game called Monster Maze and using Git Copilot and the debugger. It's fun, simple, and covers all the essential Python concepts you need to know. Picture this. You're stuck in a maze. Each turn, you move through rooms, pick up items, and fight random monsters. Your goal? Find the magic key to escape. This simple game will teach you everything about Python. I will be following the course notes that I have left in the GitHub repository that contain all the information and code blocks. You can find the links for the notes and the Python code below. Now, let's dive into the step-by-step coding process. We'll start with imports and comments. First, we need to import modules. The import statement lets you include code from other modules in your program. For example, we import the library random like this, import random. This gives us access to functions like random.randint, which generates random integers between specified values. You can open the library that you are referencing and see it by simply doing Ctrl+click in Visual Studio Code. If you are still not using Visual Studio Code and Git Copilot, check out my first video in this channel. Comments are written after the hash symbol. They help explain your code and appear in green or gray in most editors. Next, let's talk about constants and lists. In Python, variables meant to stay unchanged are written in all caps. This is just a convention. Python doesn't enforce it, but it signals to other programmers that these values shouldn't be modified. Lists are ordered collections that store multiple items of any type. They're created with square brackets and items separated by commas. In our monster maze, we define constants as lists. We have rooms containing hall, kitchen, library, dungeon, and garden. Items with sword, potion, and shield. And monsters with goblin, troll, and skeleton. Lists are incredibly versatile. You can access elements by index, rooms 0, returns hall. You can find their length with len, rooms. And you can add elements with append or insert, and iterate through them with for loops. Later, we'll use random.choice to select random elements from these lists, creating unpredictable gameplay every time you play. Now let's explore global variables, functions, and printing. Global variables are defined outside functions and can be accessed throughout your program. Our found_key variable starts as false. This tracks whether the player has found the magic key to escape the maze. Now let's explain functions. Functions are reusable blocks of code that perform specific tasks. They organize code, improve readability, and let you break complex problems into manageable pieces. Here's a simple example with a counter. We define a function called increment using def, followed by the function name and a colon. In this case, the name of the function is increment. The indented code runs every time we call the function. To modify global variables inside functions, we use the global keyword. To know what is happening during the program execution, we use print. The print command writes values to the terminal. It's your main debugging tool and the way to communicate with users, like in our print_welcome function. Functions can have docstrings, those triple-quoted strings that document what the function does. They're essential for code that others will read and maintain. Let's dive into dictionaries, one of Python's most powerful data structures. They store data as key-value pairs, like looking up definitions in a real dictionary. Dictionaries are created inside curly braces. Our create_player function returns a dictionary with the player's name, health starting at 100, an empty inventory list with square brackets, and a random starting location from our rooms list. You access dictionary values using their keys. For example, player health gives you 100. You can modify values too. Player health minus equals 20 reduces health by 20 points. Lists of dictionaries are perfect for storing multiple records with named fields. Imagine tracking multiple players, each with their own stats and inventory. Tuples are like lists, but immutable and inside parentheses. Once created, their values can't be changed. They're perfect for coordinates or fixed data like RGB colors. You can unpack the values inside a tuple to other variables. Tuples can contain mixed data types like lists and dictionaries. Tuples are immutable, but if they contain an object, that object can be modified. Slicing lets you extract portions of sequences using start, stop, and step parameters. You can get the first 2 items, the last 3, or even reverse entire sequences. Pause the video and have a look on these slicing examples. You can slice a list in a range of consecutive elements. You can do it in Revere order or at equal intervals, or you can even slice strings. Moving on to functions with input and output. Functions with input take parameters when called. Functions with output return values using the return statement. Our create_player function is a perfect example. It takes a name as input, creates a dictionary with player attributes, and returns that dictionary for use elsewhere in the program. Python also supports functions with unknown numbers of arguments using *args for positional arguments and *quargs for keyword arguments. args collects extra positional arguments into a tuple. You could create a function that sums any number of numbers, whether you pass 3 numbers or 10. *Quargs collects keyword arguments into a dictionary, perfect for functions that configure settings with any number of options. You can combine both *args and *quargs for maximum flexibility in your function designs. Conditional statements are the decision-making backbone of programming. They use if, elif, and else to execute different code based on whether conditions are true or false. Our describe_room function demonstrates this perfectly. It checks if a random number is less than 0.4. That's a 40% chance. If it is true, then the player finds an item. If it is false, they find nothing. Random.random generates a float between 0 and 1. Combined with conditionals, this creates the unpredictable elements that make games exciting. Complete conditional structures follow the if-elif-else pattern. If the first condition is true, run that code. If false, but the second condition is true, run the elif code. If all conditions are false, run the else code. String formatting makes your output dynamic and readable. F-strings, introduced in Python 3.6, are the modern way to embed variables in strings. Just start your string with F and put variables in curly braces. Much cleaner than concatenating strings with plus signs. Escape sequences like \n represent special characters. \n creates a new line, \t creates a tab, and \quote lets you include quotes in strings. Random.choice selects a random element from any sequence. In our game, it picks random items from our items list. This combination of conditionals, randomization, and string formatting creates dynamic, engaging gameplay that feels alive and unpredictable. The range function generates sequences of numbers, commonly used in for loops to execute code a specific number of times. Range of 5 gives you 0 through 4. Range of 2 to 8 gives you 2 through 7. Range of 1 to 10 by 2 gives you 1, 3, 5, 7, 9. Our move_to_new_room function uses list comprehension to create a list of all rooms except the current one, then randomly selects from that list. This ensures the player always moves to a different room, preventing the frustration of staying in the same location. The same logic could be written with range. iterating through room indices instead of room names directly. Comparison operators compare values and return Boolean results. They are equal to, not equal to, less than, greater than, less than or equal to, and greater than or equal to. Logical operators combine multiple conditions and requires both conditions to be true, or requires either condition to be true, not inverts Boolean values. Our game loop uses the operator to check if user input matches expected values like yes or y. You can combine operators for complex logic, like checking if health is low and a potion is available, then using the potion automatically. The monster encounter function shows this in action, checking random chances and inventory contents to determine battle outcomes. While and for loops control program flow by repeating actions, while loops continue as long as a condition remains true. Our game uses while true to create an infinite loop that only exits when the player enters valid input. This prevents the game from crashing on unexpected input. To prevent truly infinite loops, you can add counters that limit the maximum number of iterations, giving users a limited number of attempts before moving on. For loops iterate over sequences like lists or strings, executing code for each item, perfect for displaying inventory contents or processing collections. Recursion occurs when a function calls itself. Our game_loop function calls itself when the player moves to a new room, creating a chain that continues until the game ends. Every Python script follows a specific execution order. Python reads from top to bottom, defining functions and variables, but not executing function code until called. When a function is called, Python jumps to that function, executes its code, then returns to where it left off. We use the common Python pattern of defining a main function and calling it only when the script runs directly, not when imported as a module. Flow diagrams visually represent program logic. They help you understand complex code and identify potential issues before they become problems. Circles represent start and end points, the beginning or termination of processes. Arrows connect symbols and show the direction of flow through your program. Diamonds represent decisions, yes/no or true/false questions where the program chooses different paths. Rectangles represent process steps, operations or tasks where something gets done. Cylinders represent data storage, databases, or files where information is kept. Here's the complete flowchart for our Monster Maze game, showing how all the pieces fit together from start to finish. And here is the trick. When you land into code that you haven't written or haven't seen for months, you can ask your LLM to explain it to you, and also to create a flowchart from a project or from a code file. Then you can ask him to take you to the part where it does this or that. Debugging is the process of finding and fixing errors in your code. Print debugging involves adding print statements to display variable values at key points. Here's an example of adding debug print statements to check player health values. The Python debugger, or PB, lets you pause execution and examine your program's state interactively. You can import PB and set trace points where execution will pause. Then you can execute Python commands in the terminal. When you have finished, you can either type exit or continue. VS Code offers visual debugging with breakpoints, step-through execution, and variable inspection. Click in the margin to set breakpoints, press F5 to start debugging. It is good to know that these tools exist if needed, although most of the time you will be asking your LLM to fix the bugs. Anyhow, good debugging practices still apply when vibe coding. As much as you can trust the work of your LLM, you need to keep the things under control as your project grows. So it is important to start with small testable pieces and build your project testing one feature at a time. And to be more professional, you should automatize the tests so you can run them and check them on each change to make sure that nothing gets broken. Refactoring and documenting the code is also indispensable if you are not doing throwaway code. Refactoring is the process of improving code structure without changing behavior. It makes code more readable, better organized, easier to maintain, and more efficient. It is good practice to refactor when you have a working version. Find repeated code that you want to put in a function or an object. When you have functions that are too long or do too many things, or when naming could be clearer. Follow code structure best practices. Single responsibility principle, don't repeat yourself, use consistent naming, create modular designs, and separate concerns. Our monster maze follows good structure with focused functions, isolated game flow, and clear descriptive names throughout. UI polish improves user experience through clear instructions, visual enhancements, input validation, consistent messaging, and appropriate pacing. It is very important, so we will look at it again in future lessons. Our game uses emoji icons for key moments, clear prompts for user input, new lines for visual organization, and consistent feedback for all player actions. And here it is. We have gone through the Python basics and built the Monster Maze game. I hope you have learned to move around VS Code, practiced using Git Copilot, the debugger, and learned the basics of Python. If so, are you able to answer these questions? What happens if a function doesn't return anything? How do global and local variables differ in the game? What type of loop would you use for repeating until a condition is met versus looping through a list of rooms? How can you avoid infinite loops? Can you break the game by entering unexpected input? These reflection questions will deepen your understanding of Python fundamentals. Now it's time for exercises. Try modifying the items list to include new weapons like laser, bow, or fireball. Another one, update the monster encounter logic to recognize them. Create a monster_stats dictionary giving each monster a strength value. Compare it to player health for more strategic combat. Add an experience system where defeating monsters gives points. At 100 points, print level up. Track which rooms you visited and display a mini-map at the end. And that is it. Congratulations! You've completed your Python adventure through the Monster Maze. You now understand Python's essential building blocks, data types, functions, loops, conditionals, and debugging techniques. More importantly, you can now read and understand code that AI agents generate. You're no longer a passive observer. You're an active collaborator in the coding process. But also remember, you can ask the LLMs to explain their code, to create flowcharts in Mermaid explaining it, or to extract parts and use them in examples. Take these skills and apply them to your own projects. Experiment with the Monster Maze code. Build upon it. Test it, break it, and fix it. That's how you truly master programming. Remember, every expert was once a beginner. Every complex program started with simple functions like the ones we've explored today. Keep coding, keep learning, and keep pushing the boundaries of what's possible. Thank you for joining this Python adventure. Until next time, happy hacking!